my first office was Esther's office.
Yeah. Did you actually have windows when it was your first office?
No,
or do you have now?
I do now.
Okay, good.
Yeah,
Not that first one, no.
All the best office in the building. Then I became pardon chair, and now I'm back in the regular.
All right. Well, good.
Anyway, you're here.
Yeah, thanks for the invite.
Yeah.
The on point and entertaining.
Well, I need to go get my little intro.
There's like an evaluation sheet
Well,
that you're filling out.
it's actually a required course for grad students. That's how you get insurance. That way we have a.
Mind if I load up?
Go ahead, yeah.
Either go through drop off. Let me see if the USB works.
Yeah, USB would be the most direct and easiest way.
Western Michigan University. No, boy. More like a student system.
Not just. I mean,
I am
the IT guy. My wife's also an IT. So.
I'm an instructional professor, but I'm just making sure that
Oh, okay.
screens
There you
work.
go.
Not just.
Yeah, there you
In
go.
this role. So I think you ought to be good to go. Just the presentations over here.
All right. And
As long as you hit the go button.
notes will be over here. Perfect.
Got it.
Looks cool.
All right, there you go.
I've got a minute long intro for you.
That's about everything that I've accomplished in my.
Well, yeah.
That's about it.
Nah. People don't need.
No, and especially now that I know that they have to be here.
Well, actually, they go full faculty. Those have also being behind us every week. We should be here. We should be here. And there are some faculty who will be.
Well, I finally found the website. I saw the list. I was like, oh, I might show up for a couple of the later ones.
Yeah, you should show up. You're invited. It's kind of unfortunate. This semester there was a bit of a conflict. We usually have 3 topics, and then there's time to but
This semester, I panicking in my office because I saw a previous year the ones you had sent me for 3 o'clock.
yeah, no, that's
like,
but this semester, because there was a scheduling screwed up, and so they say we have to have 1 pod.
so are you the instructor on that?
No, I'm not. Jane Southworth is, department chair.
Jane,
She has, some in Mexico and a lot in Honduras.
Okay.
Yeah, a lot of stuff in Honduras. She's mostly been working in Southern Africa lately and in Ethiopia,
Oh, okay.
of all places. But they got the NSF grant to got land grabbing and how that changes.
Cool.
Yeah.
That's pretty nice.
Well, she taught me something about it. I've been working in Cambodia for a while. There's a huge bunch of land grabbing going on there too. They actually, the government issued.
Are they like putting in big parcels and saying, now go grab it, or people?
No. What they're doing is they have people. Land 10 years really weird in Cambodia, because the Maroons were in, everybody lost their land. Now they went back to the land. It's very poor land titling system. And so what's happened is the government has established something called economic concession zones, ECZs, that they just draw a big map with a big line around a huge amount of land, and then an NGO comes or a multinational corporation comes in and buys the concession, and then they clear out all the people who are living there. And then they put up huge, rubber plantations,
palm oil plantations.
Not so much palm oil there.
No, I don't think Central American.
You go to this, the next one?
Oh, that's good.
Yeah.
That's good. Yeah.
Just make sure you like it too.
Well, I think
You've got to wait for the kettle. We have to fill.
Okay.
Why we're all in here?
our entrance down here is put back into the pod.
Well, I'm gonna head back to our feet.
Oh, that's right.
I'm gonna go back to paradise.
That's impossible on the coast.
They were talking about going live cycle to see the tea, and then they decided not to. They own a house on an island in Lake Michigan. Yeah. And they decided that we didn't need a house at Cedar Key. A house up there and a house in Mason. And so they decided not to get a house at Cedar Key. We're in a rental house now. Yeah. And then so in the summertime, they go to the So where's that view? It's a 2-hour drive.
Golf or just? It's golf.
It's that's the view from my yeah, it is. It's amazing.
How are you? Seats here. Okay, that's right. But we need a little name tag.
Yeah, oh, yeah. It's like my house right here. Right here. Leslie and I have 7. Well, 4 of them are kayaks. And then I have a sunfish, I have single skull. Yeah, yeah. So,
Oh, okay, so it's south.
yeah. And then
Yeah, I guess it's really not too far.
it's almost directly south. Well, it's actually very close to the left. You're Pleasant, go down Williston Road. Williston Road goes all the way to 19. 19 goes all the way to. It's very pleasant drive, except for the top lights.
Hey, how's it going? Eugene, that's right. Oh, that's right. The way. Yes, I don't recognize you because you're in 3 dimensions. You know, it's always been, you don't have like a fake background behind you. Oh, yeah. It's nice to see you in person. So, yeah, my doctor. Yeah. Yeah. Sometimes I'll do. Well, that's nice. Like I recognized you out of the corner of my eye, and I was like, he's gonna come back, and I don't remember who it is. I wouldn't even figure you like I saw. Well, it'll be very different from what Lou is doing. Yeah, this is. Yeah, she is. She's actually sending tomorrow. Her first paper will probably go out to paper. So she's in good shape. She's still got to work her paper. But then once she gets this cleared out, she can go into the second paper. She should be graduating in May, so we're hoping to do it much. We're trying to keep her on camp time assistance. She can kind of do so she's kind of slowly got back to work, and then she's going to be back in January half time, and then hopefully finish, and then see if she wants to probably get out anywhere, but maybe postdoc for a year. Okay. All right, nice to see you. In person.
Here.
Logged on to the Zoom meeting.
Oh, I can get off over there.
Make him save your place.
I guess I should share the screen. Oh, I am screen sharing. There you go. Yeah.
I'm seriously.
Not the IT
Just gonna keep back. Go all the way. Last time I saw you here, I thought to get here early. I was the same spot. Wow, so James ready next.
I think we did.
Jane, you up to? James out.
We met, I think we were
It's all tomorrow. Okay, another 45 seconds.
Yes, you better. I just have some cues to remember what I'm supposed to say.
Yeah, just make yourself
That'll be easier.
All right, good afternoon. Gone quiet, didn't it? We're welcoming today Tim Murtha from the currently Associate Professor of Landscape Architecture and part-time in the Center for Latin American Studies. He also is affiliated with the Departments of Anthropology and Urban and Regional Planning. He was one of the founding faculty members of the Florida Institute for Built Environment Resilience. He previously taught landscape architecture at Penn State, which is where he got his PhD as well in anthropology, and a master's in anthropology at Penn State. But he's a Florida boy originally. He's BA in anthropology at the University of Central Florida. So he went north and came back like several of us. Boomerang Florida. He's an anthropologist, a landscape archaeologist, and a design educator with 20 years of research studying settlement patterns and landscape history in the lowlands of Mexico, Guatemala, and Belize, as well as Northern Europe and North America. He is interested in coupled natural human system dynamics, has several National Science Foundation awards from the CNH program and the HSD program earlier, which were very difficult competition. Very few of the proposals get funded. He has had over $4 million in research funding from NASA, NSF, National Park Service, National Geographic Society, and several NGOs. So anyway, but he does rely on advanced geospatial tools, so he fits right with us. So Tim, you're going to talk about settlement ecology and landscape intensification across the Maya lowlands.
Thank you. Thank you very much, Mike. It's kind of neat to be here with Mike because he gave me the introduction, because Mike and I have friends and colleagues in landscape architecture from Harvard that I got to know him before I actually met him, so which is kind of strange. So thanks for the invitation. This might be a little archaeological for you, so I apologize. I wasn't sure exactly who was going to show up, so feel free to just stop me if I get cruising through things and you have questions about anything I put up there, because part of the reason why I'm here is because of the fine work of Whit Schroeder, who is a postdoc that works with us in Fiber, and he's been working on this project primarily. So if you have any questions, Whit's probably the one that's going to answer most of the technical questions about this. But no, it's a good opportunity for me to be here, work on some things, because we're in the middle or going into the third year of our NASA grant. And this is the time when we need to kind of amp up our analysis. So really what I want to do is give you an introduction, and then spend the second half wandering around 4 papers that we're working on in different stages. And just to provide a kind of a broader arc and narrative, if you don't mind, I'll just start and get into it. If you have any questions, like I said, just interrupt me. So the, let's see if I can get this working. There we go. The overarching purpose of our research is to investigate long-term patterns of landscape resilience in the lowlands of Mesoamerica. And to do so, we're collaborating as an interdisciplinary team and an international team of researchers from Mexico, Canada, and the United States. We're looking at these landscapes by relying on advanced geospatial technologies, field surveys, soil science, remote sensing, and specifically mapping technology developed by Florida's Gator Eye program in IFAS. It penetrates the dense tropical forest. But we begin our research by repurposing big data from NASA, which were environmental surveys measuring above ground carbon stocks. Stripping the vegetation revealed incredibly complex and clearly long-term patterns of land use across thousands of kilometers of lowland Mexico. Today, much of the region is completely covered by tropical forests, some modern development, but it's clear that in the past, dense settlements and intensive land use covered this portion of the Maya lowlands. Now, much of the exploration of the lowlands, if you looked in archaeology and read the newspapers, would be focused on big architecture, warfare, but we're interested in a different story, a story about household and community and landscape resilience. What you can see here are ancient households, and these were there over the course of, say, 2,000 to 3,000 years, depending upon where they are located. They're situated in complex patterns across this forested landscape. People and communities adapted to the changing environmental conditions and rainfall, designing what appears to be a resilient mosaic of land use, including terraces for cultivating corn and other crops, and even catchment features for conveying and storing water. To better document these landscapes and how they were designed, we capture incredibly high resolution LiDAR samples using that drone that you saw earlier. Literally millions of data points are captured at our sample sites so that we can better document how this highly managed landscape functioned over centuries. We've processed and analyzed and annotated hundreds of samples across the Yucatan, Campeche, and Chiapas to better understand at a large scale these compelling stories of landscape resilience. We're also working on the ground though, and in the field, thankfully again, after a 2-year absence, to better understand and to better connect this information to see how the past can better inform or better help us understand and have an impact on the future. But two individuals started investigating these very same questions 50 to 60 years ago. So this isn't a very innovative set of questions if you look back in history. Bill Sanders, who is one of my advisors, he wrote The Cultural Ecology of the Maya in 1962, asking 2 core questions. And he's the guy right here. 1, what are the interactional patterns between environment and the subsistence system? And 2, in what ways are the latter related to population history and settlement patterns? And then Billy Lee Turner, while a graduate student at Wisconsin, shown right there, published an important article in Science in 1974 while as a graduate student, asking these same questions, but this time not from the lens of population history and settlement patterns, but from the lens of agricultural history and a very Boswellian notion of intensification. So we're building on this research of, say, 50 or 60 years and asking some very specific questions. So we're looking at what are the environmental factors influencing the distribution of domestic architecture and households across the Maya lowlands? Are these factors uniform? What do the structures and the distribution of them tell us about the organization of past land use? There are a lot of assumptions built into archaeology, so I'll try to tell a little story about that. And how has site-focused research, because typically in archaeology, it's focused on sites and not open space. When you don't find anything, you failed. And when you do find something, you probably make more of it than you should. So we're looking at this from a kind of more of a balanced perspective, I'd like to say. We're looking at what are the regional factors influencing agricultural intensification across the lowlands, spatializing this sort of question, not just relying on the pressures of population pressure, but also looking at the opportunities that the households and the communities might have explored. And then looking at how does the legacy of this past land use compare to modern patterns of land use and landscape transformations. And this is the area that we really need to flip on the NASA project. So I don't have a lot of good information yet, but I'm meeting with our team, one of our team next week in DC to kind of push that forward. So I'll try to tell these stories as best I can. But I will say that despite the focus of all this, we're really also looking at a very humanistic endeavor. And Pierce Lewis, who is a great cultural geographer from Penn State, writes these quotes about landscapes. And you know, our human landscape is our unwitting autobiography, but to be sure, these things are really hard to read. And especially when we have all these fragments of modern development or modern forests encroaching on places that are now in ruins, trying to piece these narratives together or get these torn pages together has been a really complicated process. But were it not for brilliant minds like Dr. Schroeder over there and the whole team, I think we're getting there a little bit closer bit by bit. So the arc of the presentation is focused on kind of a timeline here. I'll give you an introduction and brief overview to Maya cities and landscape so that there's some context to this, especially about the arc of how people have used and referred and talked to them about the Maya. I'll spend some time talking about one place where this was the CNH project that really kind of elevated our approach to the work, and then we transformed it into this kind of broader project. So I want to talk about one place called Tikal, and then talk about the 4 papers that we're looking at in trying to leverage the information from the Red Plus program LiDAR data sets and how we can kind of better understand a fuller geography of land use and transformations in the lowlands. This is the portion or the location of where we're really studying. We're asking core questions about these places. These are some of the kind of key sites in the region, but if you're really looking about it, it's Quintana Roo, the Yucatan, Campeche, Chiapas. You've got Belize, Guatemala, and parts of Honduras in the Maya lowlands. You'll see the database that we're relying on right now. We have to expand our geography into Guatemala, although I will talk about Tikal, which is in Guatemala and where I've worked, and we have a basis of work in Belize. We haven't integrated those data into this project yet, so we kind of end at the Mexican border. But scholars in this area have spent the last 5 decades since Dilly Lee Turner and Bill Sanders writing these papers, investigating the shape, form, and structural density of Maya cities, largely testing sociological conceptions about what it means to be urban and urbanism, but clearly emphasizing demographic characteristics. So Maya cities are perceived, and I would argue also portrayed as pre-industrial cross-cultural anomalies in that they are normatively dense and functional urban places overcoming the challenges of the lowland environment, largely due to engineering efforts. So that's kind of the current model and perspective, although it is hotly debated and there's lots of arguments, and we can talk more about that shortly. But it largely comes from a previous story about the Maya that was very different up until Bill and Billy Lee published their work in the 1950s and 60s. And moving on into the 70s, everybody kind of portrayed the Maya as, again, a cultural anomaly living in this dense tropical forest. You can look at the work of Betty Meggers and lots of people at this time, which viewed this portion of the planet as underdeveloped, hot, messy, and impossible to actually have large cities. And this is a quote from Catherwood and Stevens. Well, Catherwood did the drawings of a place called Tulum, and everything they did visually and through their language really kind of framed the Maya as empty centers, religious centers, and not as lived in places. And that kind of lingered for a number of years until right around the 1990s, people started to question this work, and the pendulum swung completely in the complete opposite direction. And Maya cities are now viewed as lived in and urban, but the degree of form and character and the dynamics of what urban means is still kind of, what does that actually mean? And from my perspective, the pendulum swung a little too far because a great deal of recent work has been attached to a series of secondary, untested, and perhaps untestable and perhaps unflattering assumptions about social, political, and economic organization in a part of the world where you had indigenous urban centers developed in place in situ. And I can say that these are unflattering because these were the 2 people who gave me my start in archaeology from the University of Central Florida. And it was in this moment that I started working at that site, Caracol in Western Belize, that I started to think about these issues and try to generate different stories or different science behind studying them. And one of the first things I did was I started to look at publications, and I've discussed this in other places. I don't know if you can see that little arrow, it's a bad color for me on that choice, but the reality is in the last 30 years, the population size and density of the classic Maya has grown exponentially, even tied to new theoretical perspectives, such as Fletcher's low urban density model. Estimates for the Maya are getting higher and higher each publication year that we have. So part of that, our project was to kind of re-examine some of these questions about the relationship between sites and urban densities, and also the resources that places had access to and the landscape transformations. Basically got into this kind of too big to fail model where people were assigning a lot of people to Maya cities and places. Those populations were then also not only the impetus for intensification and land-esque improvements on the landscape, but then they also became the impetus for the collapse and decline of Maya society. So this entire narrative was built in, but it was built on a lot of assumptions, and a lot of those assumptions were about cities and how they were structured. And I've used this. This was originally drawn by Cedric Price in 1982. Then Peter Weller redraws it, who's at Penn Landscape Architecture. And then I just recently redrew it for a publication because in some ways, the Maya never really fit these kind of urban models that we were getting from the Chicago school or the German school. And that was really one of the key problems that we were looking at. Early on, people thought the Maya were these walled cities where you had people in the middle and agricultural landscapes outside. Later on, we got a little looser with that model and started to think of it more as a fried egg. And then even later, it was more of like an omelet. And I have maps to prove this. So early on, this is Tikal, one of the places I'll look like. And these are actual maps that came from publications. This is Chunchukmeal. Even the date on this is most of the work was done there in the 1990s. And then more recently, this is going back to Karakol, where it looks a little bit more like an omelet. And the idea is simply this. People have been trying to force the Maya into these urban models for 5 decades. Ever since Bill and Billy Lee kind of published these articles about the possible transformations of this place. And so how could we get back to ground zero, try to have another better understanding of what happened and what we could technically build from these places? For me, I think the part of the problem is really the yoke. Even when conducting regional studies, everybody focuses in on the center of sites because that's where your monuments are, your big architecture. And that's where it's usually easiest to access. But the more we get outside of these centers, the more we see that there are densities that resemble urban densities in the center of the site, far away from some of this architecture. There are households and communities that persist in the area where WIT works hundreds of years after what people term the Maya collapse. Even at Tikal, we have dates for kind of infrastructural improvements that are 300 years after the last hieroglyphic text is carved. So there's lots of information that suggests to us that the models that we're trying to throw at the Maya, while they are great for the New York Times and for Archaeology Magazine, and sometimes Nat Geo, or sometimes Disney Plus, because WIT's got a special coming out on Disney Plus, that we keep trying to fit the Maya in there. So what can we learn from these landscapes that might be more transformational? So through our specific research, our aim is not only to answer core questions about the Maya then, it's really to kind of look at core science questions about human agency, population growth, pressure, environmental change, sometimes migration. We haven't gotten to those parts yet. Environmental management, land use, and urbanization. So we do study these through the lens of landscape. And let me start by talking to you about our work at Tikal first. And that is located in the central Petén in the Mayan Biosphere Reserve. It's a wonderful place. And if you have one place on the planet to visit in the next part of your life, please go visit there. It's incredible. It's really worth the shot. And especially so if you are a Star Wars fans, because it was very well known for the towering architecture and once home to the first Rebel base, which was there in the original Star Wars movie. But if you go back to the 1950s and 60s, Tikal was known for its impressive art and architecture. The University Museum at the University of Pennsylvania did a really incredible job pulling artifacts out of that site and bringing them to museums all across the Americas and in some ways across the world. But there was another part of that project that was really far more impressive from my perspective than the efforts to excavate and uncover these Mayan temples. There was something called the Tikal Sustaining Area Project, and this was led by William Haviland and Dennis Puliston, and it took the ideas and observations from Billy Lee and from Bill Sanders, and first took a sophisticated perspective trying to understand land use and social organization in these places. Their work remains uniquely important in part because they based their interpretations on settlement surveys. So they went out and documented, primarily Denny Puliston, went out and documented thousands of Maya households far from the Maya center. He found an earthwork or a big wall that surrounded the site, and he found households living outside what was the defensive wall. And all of this information started to come in. Nobody really knew what to do with it. He at the one time was defining a methodology that people would use for the next 30 years, but really was trying to get at the interaction between the very same interactions of resources in place that we're looking at. He drew these incredible, and these are from his notes, they're currently at Princeton. But this is a transect, and unfortunately it's backwards on here, but he was 12 kilometers away from the center of the site. And he was looking at the relationship between how much open space there was and how many households were there, and trying to figure out where the densities ended and where people could have grown crops. He had ideas about how the modern forest was a reflected niche from past 2,000 years worth of land use. Very impressive set of data. And he did this all before GIS, before remote sensing. And this was all done by hand using a compass and tape. And I can tell you, I've gone back with differential GPS. We now have remote sensing, and there's recently been LiDAR there. And Denny's maps were incredible, like drawn by hand in a hot, humid tropical forest on paper, and having done that too myself, they're incredibly well done. So I didn't actually have to remap any of his work, which was really impressive. So these are some of the questions, though, that came out of Denny's work in Tikal. It was this, still, people were grappling with the fried egg hypothesis because the densities weren't matched up, but people still tried to draw a boundary around the site and say, where does the city end? Where does it begin? And if you start to look at some of the discussions, everything's still emphasizing those demographic issues: large size, large population, strong and centralized. I mean, that sounds like something straight out of Trump's book. Largest and most important centers, the city, and then defining boundaries like city and countryside. And one thing, I don't know if Whit would agree with me, but one thing I keep trying to push now is, like, I'm not sure there is a defined boundary between the city and the rural areas of the Maya. I'm not sure that this magnificent architecture that we see is really what defines the Maya cities. There are places that we're finding amazing densities of populations where you don't have these magnet centers. And so that really kind of throws on its head our notions of vertical density and starting to look at horizontal density, I guess, when we're looking at landscapes. So then we started this project to do just that at Tikal, to build on. Nobody had worked at Tikal or looked at Denny's work. Somebody actually did, Annabelle Ford did in the 1978, 1980, but went far away from Tikal and didn't really go back to his original work. So that's what we did. We went with a civil engineer, a couple archaeologists, a hydrologist, and really wanted to understand through sampling, because we can't map everything, right? LiDAR hasn't been introduced to the extent that it is today. So you'll see some of that. So this is a pre-LiDAR project where we had to take all of our documentary information and bring it into a single geospatial system and run some models and try to figure out where people might have lived, and then develop appropriate remote sensing approaches to try to kind of expand our small samples to better understand the region. So we relied on traditional settlement pattern survey, but we coupled that to remote sensing. And there was a new NASA program at the time. So we also coupled that to some soil sampling and forest inventories. And it proved to be very effective at helping us to understand that the city itself was almost boundaryless at times, and it's hard to define the boundaries, but also at the same time, how much open and productive space there is in this city, despite it being the largest in the Maya region. At the time of the results of this project that we were working on, another Tikal project results were emerging. And this is Nick Dunning, another great geographer that has contributed to this thinking, along with Tim and Cheryl Beach. They masterfully studied the center of the site while we were looking outside. And they were focused on water management and land use as well. But along with the hundreds of buildings, central causeways, palaces, and monuments, they documented this really well-designed reservoir system that collected water diverted from buildings and plazas, and really kind of gave us some ideas about how we might want to look on the landscape to try to find similar relationships here. So what you're looking at here is just a Landsat 7 ETM plus, and what happens in this part, at least in March, is you can see patterns of past land use using very kind of late dry season imagery. And in this case, you can kind of see this urban built up area. This is the center of the city. And we were starting to see pockets in other areas. We found sections of the place where there was nobody living, and we have not documented a single physical feature there. And our soil samples don't show any evidence of past maize production. So it's an interesting place. It's a little hard to get water. We found new portions of a wall. And it turned out that that wall was not necessarily around the site, but negotiating these different boundaries. You can see other pockets of dense architecture here. Tried to highlight those. And then these large drainage bajos, swampy places, just like we have here in Gainesville. We also used, and we were lucky to have this at the southern boundary of the site. So while Nick and colleagues are working in here, we're working all the way around up here. We had farmers that we could talk to down here that were already clearing landscapes, and to talk to them about what was happening on a year-to-year basis. We learned a lot from them about just how dynamic their perceptions are about the landscape and how quickly they will shift and move to different parts of the landscape in order to modify their production on an annual basis to meet the demands of their household or market demands. But at the same time, they weren't set into these kind of rigid normative models about production, like we only produce here, and they would shift based on annual precipitation. Because you get about 1,500 millimeters of rain here per year. But if you look at the historical records, it's never been 1,500. It fluctuates wildly. There are periods of drought, and you don't have a natural water source within 20, 30 kilometers. So you have to do a lot of maintenance on your water system. And what Nick and colleagues were able to show in the center of the site was that it was well cared for and managed. We looked outside and saw very similar patterns, although maybe not as built environment, not as cementy as other places, but we found pockets and communities living all around this city that found a balance between land and water, basically. And this is just another one of those. The new model of urban Tikal was one of agglomeration in different parts and relying on localized resources. And like Brookfield talks about in the 1980s, when he's talking about intensification, there were social patterns of intensification probably at work here at Tikal. I'll get to terracing in just a second, but I went to Tikal expecting there to be land-esque improvements on the landscape. People had talked about it for decades. You have to find terraces, you have to find wetland fields because cities need that in order to support their population. And what I think we ended up finding out was that supports, and if you know Brookfield, he writes in '84, this new model, it's not counter to Boserup and Malthusian approaches and Geertz approaches to intensification, but what he's writing about is that there are other ways in which people intensify. And some of it could be through social organization. And it seems to be the case at Tikal, not to give it away, but we focused on these small little communities and then studied trace element analysis of different soil profiles along with a vegetative survey to try to see where people were producing on this landscape. And we had different models, right? Oh, people won't produce in the swamps because the soil's too clayey and too difficult to use. People only use the uplands, but then there was massive amounts of erosion in these places. So we took 250 some odd soil profiles all around the site and started to notice some significant patterns. In addition to being significant environmental changes at Tikal, there was also evidence for intensification of agriculture throughout the site. We could not find a place that didn't have strong evidence for intensification unless we had lost that soil due to erosion. Richard Terry did this work, but you looked at C3, C4 enrichment studies, and just shown here in profile, I picked the best one, right? This is one that we had a substantial difference in soil color to match to our trace element analysis. So what happens here is maize is an invasive species. Even though it comes from this part of the world, it's actually an invasive species to these environments. And so it leaves an impact on the landscape if you have sustained production. The one thing we can't do with this is quantify the amount, but we can at least identify different parts of the landscape that were used. Two significant things came from this. So again, it's the erosion, but it's also agriculture everywhere. So we went out and tested some of these bajos, and we started testing in areas where some of the modern farmers, because if you had noticed, well, if you had gone back into the 1950s and 60s and looked at some of the Kilson stuff, these areas were cut off. They were basically said they're useless except for natural resources and they would not be used for agriculture. And we found massive amounts of evidence for use of these soils. And then after talking to these farmers, we started to realize that sometimes these are the best soils because they're retaining the water in those really difficult years. But sometimes you had access to different resources really close to the site. And I think that was what was striking to us. Instead of having a city with your densities of population in the middle and agriculture outside, we started to see this kind of overlapping pattern of agriculture everywhere. No doubt, the earliest residents of Tikal weren't magicians. They really impacted their landscape through deforestation and erosion. The earliest farmers we know created real serious erosion issues right around these bajos. We can track it. But at the same time, once that landscape's managed, it is productive for 800 to 1,000 years, if not 1,200 years, depending upon the dates that we look at and how you look at it. And so that productive soil, even though it was eroded, some of the hill slopes, it was just shifted on the landscape. And so settlement patterns kind of shifted toward those margins, foot slopes, and toe slopes of these bajos. So the city design or the social system that was organizing land use probably shifted its focus around these resources. And what I would expect is some form of communal labor organization providing access to this. Now, it's clearly complicated because what we also see in this landscape is that there are these walls being built. And so people are negotiating boundaries here, but not as a city versus other cities, probably trying to understand the inner workings of the social structure that's associated with land use here. Anyway, one place can't tell us that whole story. So we took the observations from our square kilometer area that we intensively studied. We took our vegetation surveys, and then we attached the soil analysis and looked at 24 predictors from remote sensing variables, just to try to see if we could understand the distribution of these resources. And so we were able to kind of, using the work of previous forest surveys, look at this as a lived-in forest, not necessarily to say that the Maya actually created niches of forest based upon their actual land use, but their direct and indirect behaviors left niches. And those niches were very visible to us in remote sensing and certain variables from remote sensing. So we were able to kind of establish what was the most sustainable parts of this landscape. Using the maze model again, we had positive identification for intensive production, and then we would scale that up and look at the variables. And what we saw was a really kind of circular distribution of open space, productive landscapes, and households all across this landscape. So the center of this city actually had quite a bit of productive landscape. So the city's here and all this wonderful resources right around it. But as you can see, there's pockets everywhere associated with it. Now, these blank spots weren't not used. They were certainly part of it, but we were trying to find where's the stable resource here, and does the settlement pattern match it? So instead of having a consistent density of high population in the center to the lowest outside, what we were seeing are these dense pockets of settlement adjacent to these red areas where we had these great resources. Looking at it in section, just a different way of looking at it, the regional ecological systems, and probably associated with that past erosion, really influenced Tikal's city design. Instead of packing households together in high densities surrounded by an agrarian landscape, Tikal reflected an early form of what we would call ecological urbanism. And so here I've just tried to kind of quantify that based upon the observations in two transects going west to east and south to north. In south to north, you see a higher population that has a little bit to do with the topographic position here and not having those bajos. But we can really see that there are these kind of pockets of population that were almost balanced the ecological systems that were adjacent to them. I'm going to try to cruise a little faster. So that brings us to 2017. It's the year before I come here, and we started looking at, and it was back a graduate student at the time, we started looking at these data from NASA that I'm about to show you. And the question was really, are all Maya cities like Tikal? If you were to look at most of the popular media approaches that look at Maya cities, you'll see these megalopolis references. I don't think that they're any more flattering than assuming that the Maya had a middle class. Hidden kingdoms of the ancient Maya revealed in 3D laser. I mean, this is all very exciting, and you can see here's Tikal shown. And this is wonderful to see the press, but the idea is still kind of focused on these cities and centers and the densities in these centers. And so the trappings of our core questions still remain. I mean, we do have Bill's first question, as he tried to draw a map of the entire Yucatan Peninsula, and this was population in the 1940s. He was trying to use that as an emphasis to try to understand where the Maya would have lived. And again, I'll get to Billy in a second. He was trying to understand where the landscape information was. And if you can see, there's a disconnect, right, between those two maps. We're essentially trying to bring these two maps together using LiDAR. So we modeled the settlement distribution first. To address this question, we embarked on our project. Now we're looking again at these long-term impacts, and we identified these samples that are shown here all across the Yucatan that were taken by Woods Hole and the NASA G-Light system in order to, again, better calculate above ground carbon stocks. And the interesting thing to us is that these samples there were 610 that were taken from this region, and they were processed, covering over, they're from 3 hectares to 4,100 hectares apiece. And they connect well-sampled areas or areas where we know a lot about the Maya to areas where we don't. So each one of these little dots is a known site, and it's not a perfect map, but the major sites are in the big dark black. They're called type 1 and type 2 sites. These are the big city centers. And just a reference to what it could be a small clustering of households or all these little dots. But you can see that the G-Light did a really nice job of not hitting a lot of the major sites and focusing in on these areas in between. In 2 previous papers, we documented the variety of structures and the importance of this. And so I'll talk a little bit about that because we processed 458 of those samples. And by we, that's a loose use of pronouns because really it was with and a couple of great students that helped. But identified 5 feature types. It was structures, platforms, plazas, reservoirs or holes in the ground, basically, causeways, and then also we have architectural terraces, agricultural terraces, walls, canals, and paths. That sounds like more than 5, but we have subcategories, so not to confuse you. Now, these tiles are colorized here for the structure densities. And what was really interesting is when we first did this distributional model, is we started to see that there were really kind of the highest densities were in areas that were unknown. And if you look at modern archaeological sampling in science, it starts at the site and goes outward. And so we were seeing a real disconnect there. Not that we were claiming to find new giant sites, we just saw high densities of population. And this is what some of these samples look like. We would sometimes get some monumental big architecture, but we were getting lots of clusters. These are small households. The Maya lived in these plaza-based households where they had multiple houses fronting a plaza. And that's the kind of unique part of the work that we do there, because most other archaeological projects are dealing with just a hump of nothingness, right? And then trying to calculate out from that, and you have to dig into it. The Maya were so thoughtful that their houses, individual houses and activity areas are very well defined on the landscape when you walk around, and when you get LiDAR to pull the trees off. So we can size them up. And I'll show you what we're going to do with some of these data. Just let me get through the different feature types so you can see these. So this is what some of them more look like. This is some of the terracing. This comes from the area that Billy Lee Turner's original science article came from. And it confirmed a lot of his ideas. But something that was interesting here, I remember having a conversation with Bill, and this is when I was in grad school, not in the 70s, Bill Sanders, not Billy Lee Turner. And he said, I don't think Turner knows what he's talking about. Those look like walls, they don't look like terraces. And these two went back and forth all the time. But both of them were right, because then we would find places like this where you'd have these incredible contour terraces, but then you have these wall boundaries. And I will tell you, these are the most interesting features Whit and I are looking at, but we don't have a clue what these mean. I mean, there's assumptions about this being land tenure based, way too complicated and way too premature. So I'm not going to talk about the walls, but we have something to work on over the next year, because that's never really been addressed. The only walls that people talk about in the Maya area are kind of like the southern boundary of the United States. It's like to keep people out. That's not what these are. There's something different going on here. So we still have a lot of work to do. Our field work in the spring should hopefully do that. But you can see there's households here. This is households living in areas where most people would not expect the Maya to have households, in the Bajo or the lowland parts. The expectation is that they're in the upland areas, and resources come from the lowland areas. All right, so let me give you some of the stats of the structures that we found, starting with domestic architecture. Again, this is the population model that we started with. 59% of the samples analyzed were located within 10 kilometers of a large Maya center, and they exhibited high densities of structures and platforms. But conversely, 38% of the samples are 10 kilometers or more from these big centers that people call Maya cities. And they show very high or high densities as well. So an inverse relationship between density and distance to some large known cities exists, running counter to the expectations of most regional LiDAR surveys. So even the ones that are coming out today, they're still focused on a permit that's around a site like Tikal, or you'll hear about something called Pacunam or El Peru, Baca. These are the sites that are being promoted. But what happens is they draw a rectangle with the city center right in the middle. And so what happens is you never get a fuller understanding of that regional system. Thanks to the G-Light, we do, I think. The correlation depends upon, though, the extent of the archaeological survey and the knowledge of a region. Just because we didn't know about it doesn't mean that there wasn't something there. I'm not foolish enough to say that. But the fact that so much has been put into it, working from the site outwards, I think it's skewed our perception as to what to expect in these places. The structure densities from this analysis, especially those from the central lowlands, are consistent with and are actually higher densities than the ones that are being promoted in some of those articles I showed you. So, but we're just not out there. I do not want to get out there in front of this and say the Maya had cities without big buildings, right? Like that would be the next thing. You might read that. If you do, you heard it here first. I don't think that that's true. But we actually have higher densities than some of those that are being reported today in parts. But these are situational densities. And I think that's where we have to start looking at the landscape as a question and not only the built environment. So when we look at a place like this, if we were to kind of shrink our hole in this and we see these high densities of features, this is a pretty big site. These are rather large mounds with some pretty formalized architecture. down here and some large terraces. I mean, this is very impressive and hadn't been identified prior to this. But we see that. And hopefully you can also see that there's a lot of other space around here that is not tinkered with. The same thing could be said for some of these other interesting systems that we're finding, where you find kind of individualized households with moderate terracing. My dissertation work, I would recommend, I would suggest by looking at this, these are household or smallholder terrace systems that are maybe associated with some of this larger architecture, but we can't directly attribute it to them. You can kind of see the scale of different changes here. A lot of open space, a lot of households, and then things like water catchment features. And then recently, Whit identified some other features that we're looking at in his neck of the woods, where we've got these canal systems. And we definitely have evidence for raised fields or drain fields, I guess I should say, in parts of the landscape where there also weren't very high densities of people living, but we can see evidence for it here. And it's really weird. We're just started. I mean, we've both only been to this place once. We're traveling into way rural parts of Chiapas to kind of track these down and field verify them. But there are these really kind of intricate systems that are emerging that aren't associated with a top-down infrastructural project, which is the expectation of most of these studies. So how are we going to start looking at this? So let me introduce the 4 papers. I've got like probably 6 more minutes or so, and then we can see if there's any questions. So just introduce those papers. And I also would love your perspectives on how we might start to address these questions. First paper is a predictive model, really trying to isolate regional distributions of population and settlement. The second paper is really looking at intensification and terraces, even though we're going to bring in these other features. The third paper examines inequality across the landscape. That's a paper that Whit started this past year with a presentation in April, and now we're working on getting it up to shape. And then finally, a data integration, like how can we take these samples and really generate those original maps by Bill and Billy Lee, but now using all these data that we've collected and kind of compiled here. So for predictive modeling, I'm not going to leave, there's too many words on this slide. I would fail my research design class, but I want them to be up there just so you can see. I mean, from our analysis so far, we really are linking these settlements and these places to regional ecological systems. So we want to tease out how these regional systems might have influenced the agglomeration and the distribution of households and settlements. And then maybe see how that compares to the previous models of places that I worked before, Caracol or Tikal. To do that, we're using MaxEnt. Part of that is because this is, when you find something in archaeology, it's like a museum collection, right? The presence of it or the lack of finding something in another place doesn't necessarily, or the lack of evidence for information of something in another place doesn't necessarily mean that it wasn't there, right? We only have positive associations on this landscape, so we have to use those. That's why we're using this. If there are any other approaches, I'd be more than happy to talk about that. We're comparing it to a number of environmental layers, and we have looked at autocorrelation. This goes from precipitation, what we know, again, what we can generate spatially, and we have to rely on what we have, large-scale data sets about soils, et cetera. What we're finding is that the most influential variables associated with this and where we would have expectations of the highest density are factors related to a balance between land and water across these landscapes. Not necessarily one resource or one approach. And that's what's making it hard to model, because the northern Yucatan has a very thin soil base. And so the influential variables there are negatively influencing our models over here. I'll talk a little bit about how we'll strengthen that. But now we're also turning to the core questions from Turner too, and trying to understand this from a landscape perspective. What does the landscape say about this? Curiously enough, I was back reading Billy's 1974 article. The article right after it is a Watergate article, 1972, campaigners tried to use research and development agencies. So I just thought that was interesting, given the times we're in. Okay, so intensification, terraces, they show up everywhere, but how do we find a metric for them? And so in this case, it was just counts of terraces by sample, and it didn't really demonstrate much except for the fact that Billy's original map was probably somewhat right, but we're finding it in different places, and this is just counts. So we need other variables to help us understand it, because the place I worked at Caracol is an amazingly transformed landscape, and we have everything from that to landscapes where you have individual households building a terrace or two. And so how can we understand that variation? So this is terrace area. What I do is a minimum boundary. geometry around the terraced areas and then compare it to the samples that we have to get some measure. So if it's a 1-to-1, that would be Caracol. They had every bit of that landscape was terraced in certain parts. But then you would get to maybe 50% or more, we're calling like a type 1. So just to show you, this is what a really intensive terrace landscape at Caracol looks like. Obviously, it looks like the majority of this is somewhere in the mid-range to the smaller scale systems. But we really need to get a better handle on that, because trying to identify, if you were to look at the literature now, most people would look at terracing in the Maya area and say, okay, the presence of terracing means this. And it doesn't. It means something very different. So this gets back to that kind of Brookfield enhancement of the intensification model. We're also then going to compare this to some of the other regional resources, just like we did. So here it's showing kind of the terraced area as compared to sample area by precipitation, right? There's a pocket here. You get a little too much rain down here. We're not seeing as many intensive. Now, am I calling that a 1-to-1 relationship? No, but I'm just trying to give you some of the observations that we're trying to work with as we play through this. Elevation, it's probably terracing is one of those things that's such about micro situational design and construction that some of these variables probably don't capture why there's this variation. But one thing that's coming up is that we're also looking at this from a kind of a conservation and understanding perspective. A lot of these areas where we've got a lot of good information about past land use that could translate into information about the future aren't in protected areas. And so I think there's a concern that we all have about making sure that we retain that knowledge moving forward. So that's the physical features of the landscape. And then looking at inequality. Recently, WIT championed this model because it's being used to study Maya cities. It's the Gini coefficient. It's also being used to look at global inequality. But because of those wonderful Maya households, you can count them and sort them, and people use that as a currency for understanding inequality. Bigger households mean wealthier. It's been something that's been studied very well and closely correlated in the Maya region. So we tried to run this across the full sample. And there are a lot, it's interesting, Whit can probably tell you about it. He's in this session where everybody's doing it based on their site. And they're saying, look, it works. We can see all the distribution of wealth inequality across this. And we tried it against here. And what we found were consistently low measures of inequality. And then, interestingly enough, probably some patterns that need to be explored that were based upon Tim Beach's Physiographic Region article, where it looks like there's some differences in areas where you've got a diversity of resources. It's potentially that we're not seeing the same high levels of inequality. So whether these are playing out correctly or not, this is the area where we've worked for 10 years. This is the area that we've done most of our field work recently. And it's a very resilient, resource-rich part of the landscape. And we're seeing the kind of least amount of inequality there, which might be telling to this greater landscape. And then finally, some questions about data integration. Anytime we're working with data like this, it's really tough to find the right scales to work with. Again, we're trying to do the airborne system. If we start with the the airborne system, and then we're using the drone to kind of find after we found areas to better map them. And then we're hopefully going to get involved with the JEDI program to scale that up across. Right now, we're using a couple of different ways of getting at that resource, just kind of clearly overlapping. So in this case, we've got G-Light, and then we have our Gator Eye on top of it. This is a place called Benemérito de las Americas. And so there's the publication for that one. But we're tying it into Google Earth Engine to try to look at composites of the last 30 years of land use history and then compare that to what we're getting from these data to see, is there evidence that past terrace landscapes are more intensively used now, or the rotation of field systems is different in these places versus others. That's a very early composite that we're working on. This, we really need to kind of pull our weight on this because we've got different samples. So I'm going to end on just a couple slides. This is what we've got upcoming, because here's the area that we've been working on, and now we're trying to do these other models. We need to always keep our heads on what we're doing next. So we've got field work in the northern Yucatan and Campeche coming up in 2023. And we also just submitted a HEGS proposal to include this area of Guatemala as part of our sample area. I already have information from this area, so we can kind of combine this and then look at that entire geography to write it. Also doing an AI pilot study, thanks to UF's like I'm sure everybody here has heard, like UF's big on AI now. Well, we got a little funding to work with Alina Zaire and Kitty Emery and Antonio Foyas to look at how we can do some automated identification. I know I've had a lot of word jumbling today, and hopefully it was at least entertaining and there were pretty pictures. But I want to go back to Denny Puliston really quick because I think he wrote about the Maya in ways and was terribly inspirational about this. I don't know if the Maya achievements were a stable balance and harmonious adjustments in the landscape. One thing I do know is that there's a lot of information to be gleaned from those systems as indigenous systems and not trying to fit them into our own Western models of urbanization. So thank you for the time, and I have a great rest of your day. I'll leave it with Denny on that. Yeah. And hopefully I didn't go too long.
No, I had the great privilege of working in this area back in the 1980s when I was there was a standing joke that you can start at Tikal and go straight north to the coast of Yucatan. You'd never run out of house now. And the Chicleros would tell us that, the people who were out in the forest all the time. Now you've got the data to show this is happening, actually. It's really true.
Yeah.
Okay, but the question I have is that what you are seeing is a static picture, but things change over time. Some of those places could have been occupied for many centuries, others for just a short time. Is there any way with any kind of structural evidence that you can sort out any sort of time?
So people are doing that. There are people who are suggesting at least you can tell the early versus the classic period Maya based upon the organizational structure. And there's a good person doing this. His name is Takeshi Inamada. He's been doing a lot of the early stuff. But we're talking gross periods. So we're talking 600 years of time periods that you can do. For each of these households, I think that's where our on the ground part has suffered the last couple of years, because what our intention was to go back out there, use Gator Eye, and then test pit and pull soil samples. So that'll help us get a little bit there. I mean, Whit started doing that this year where he's been working. So he's got a lot more temporal information. We also then, though, thankfully have, 50 years of people doing work in a lot of the regions adjacent to it. So we can start to use some of that temporal information. But that's the tough part. We're never going to have, that's why we're looking at such a macro scale, right? If you looked at any one of those households that I showed you, you could question whether they were occupied at the same time. But we want to understand kind of the 1,000-year sum total of, I guess you could call it the palimpsest of landscape first. And that's what Bill would always tell me. Start there and then work your way down to some of these details. So it's a tough one. That was the first time we got rejected from our CNHs because people were like, yeah, how are you going to date all this? So we threw in radiocarbon dates into that. So.
They only fund 10% of the CNHs anyway.
How long did this question? A little bit out of scope, but
No, I'm out of scope for this colloquium, so.
Well, this question might even be out of scope for the colloquium. I'm not sure. This reminded me a little bit of analysis of pre-colonial cities in Africa, mostly Western and Central Africa, which have also kind of a loose structure, but different, right? It's a well-defined sort of dense urban center, and then concentric circles where population is more dispersed, authority is less effective, and then there's like kind of a loose boundary that just sort of disappears into the periphery. Different sort of structure here, but I am wondering about how this kind of settlement pattern relates to authority, political power. I don't know if that's something that you.
No, I mean, that's a great question. And I try not to be so transparent with the assumptions I bring, which is like years of being an academic. I guess that's what you're supposed to do. Don't do that. Don't hide your assumptions. But no, I mean, I think, and again, I don't want to throw Whit under the bus with me, but at least for me, that's exactly what I want to fight. Because if you looked at most models for the Maya, it's very authoritarian. It's very, we control this ideologically, because all that information is coming from a small set of hieroglyphs, big architecture, and like you're saying, this kind of formalized model of authority. And so when you look at places like Caracol, and that's why Denny was kind of so interesting. Look at Caracol and Tikal, all the investment in infrastructure is claimed to be at that top level. And when I worked at Caracol, I never worked in the center. I was like, wait a second, it looks like everybody here is doing all the work, and labor is not as easily controlled. So I think your question's spot on. My hope is that through time, we'll be able to demonstrate that the relationship of people on the landscape here actually says that there was less of a controlled authority in the Maya region across that large geography, across that long time period than we think. And that's the resilient part of it. It's not actually the engineered city. They were borrowing techniques that they were getting from households distributed around the place and just applying them at a different scale. And then maybe throwing some corn parties so that they could get some labor. But I don't know how like tightly under the thumb each one of these households were. I'd argue the counterpoint first. So thanks for that question.
That's really interesting. I'm sorry, I thought you were kind of going with me, because I was getting more and more fascinated.
Yeah, that is where I'm going with it, at least. I don't know if my colleagues want me to go there.
I just have a question, so I know the perspective as well. Have you talked to him at all in terms of?
I'm scared. So Bill Sanders and Billy Lee. No, I'm so right now, Whit and I are writing up a science update to his original science. And we're gonna meet tomorrow to talk about that. And I want that to be written and then I want to send it to him. Because so much of what he wrote in there is so spot on, and he was so right about things. I hope that he'll see the positivity in it. But him and Sanders apparently didn't get along for some silly reason back in the day. And so like he even like misnamed Bill, and he like, I want to thank Barry Sanders for all his help and this is like his dissertation monograph. So like I literally am scared, but no, I mean, he also, his recent work on land systems architecture, I think, plays into this model too, because if we have gridded out sections of the Yucatan, we could better understand not only the overlay of today, but how many years of human history contribute to that. So.
I think you'd be very interested in techniques-wise as well, in terms of the approaches you use and the approaches he uses and trains his students to use. We also know.
Cool.
I think
that's good to hear.
Yeah, no, I think you'd be interested, and plus, you're kind of proving some of what he proposed. But I was interested as well in terms of the reason. I have not read that paper by Billy, I must say. But in terms of what his predictions were based on, that he was putting that out there versus what so there might be similarities in mass, but are there similarities in underlying causes?
Yes, and except I think the one thing, and please don't tell him I said this, but it was 1974, right? And so Bosworth writes in 1965, the most amazing transformative piece on intensification. Now you come back, into the 1980s, 90s, and 2000s, we realize that Bosworth wasn't really effective at understanding the spatial arrangement of things and the social dynamics at play. And that's where I think Brookfield contributes to it. I think today, Billy would look at it and say, that's exactly what I meant to say back in the day. But this was a very Bosworthian model that he wrote, right? So he went from this and said, look, the carrying capacity here is enormous and it can feed these cities. And I think he might go back and change that a little bit nowadays. So, but that's just a timing thing. I don't think it has anything to do with because he recently rewrote something about this. I think it was also in Science, and maybe it was 2009, where he started to get into some of the more dynamical relationships, and that was when he was starting to write about land systems architecture. So I think it's there. In this original piece, though, it was heavily influenced and inspired by Bosworth, which ain't a bad thing, because my dissertation is all Bosworth all the time, and I look back at it and think it was pretty good. Thanks. I hear bells ringing. Is that how you guys get rid of people around here? I really appreciate your time. I didn't realize that you had to be here. So I hope when you fill out your evaluation forms that you don't throw me under the bus. But have a great week and have a great semester.
I don't know. Oh, Lynn. Yes, Lynn. Oh, right. Sure. Sure. So, hey, everyone. Next week's colloquium will be in here. Same time. The speaker, her name is Yulin. I'm blanking on her last name, but she is an IFAS extension agent. She does work with a lot of hydrology in the state of Florida. She looks at the well network across the state and understanding how landowners make decisions and how that impacts the hydrology in our neighborhoods. So she'll be here to speak with us, and yeah, we'll see you there.
Yeah, segue from ancient hydrology.
I know, it's a modern hydrology in wells. I studied it passing in the bachelor.
That's cool. No, you spend much time with Mark Renner?